Alright guys, as you read through number 13, you're going to notice that it talks about a robot climbing the wall when you press a button, and it only climbs 75 cents each consecutive time you press the button. If that gets reduced by a certain percentage, this is actually going to be a geometric sequence. It's going to be a geometric sequence because it's going to be a geometric because the first time is going to be 10, that's the distance. The second distance is going to be 10 times 0.75. The third distance is going to be 10 times 0.75, and then times 0.75 again, which is going to be 10 times 0.75 to the second. Notice this is the first step, that's the second step, that's the third step. And then the fourth step is going to be the previous one squared times 0.75 again, which is going to be 10 times 0.75 to the third. And if you notice, the exponent is one less than the sequence number, or the amount of times where the robot is moving. So it's going to be generated by the function n minus 1 as they match. And then if you notice, 10 was the initial value, so it's going to be generated by this function itself, the distance that the robot travels on any one consecutive time after pressing the button. So like if you want to press the button 10 times, we can figure out how much he travels on the 10th time. Now this question was the smallest upper limit on how high the robot can climb. What that means is how high is the robot going to climb if you keep pressing the button to infinity? Which means we're talking about a geometric sequence. We're actually talking about an infinite geometric sequence, where this is the equation that defines it, and then this is going to be the amount of distance the robot can absolutely climb towards the end. A sub 1 is going to be 10, and we do 1 minus 0.75, and we get our answer. So on the answer of this, the total distance that this robot can climb is actually 40 feet maximum. And we know that because it's a geometric sequence, and we're talking about what's the smallest it can climb forever. And then we have a rate whose absolute value is less than 1, so there's going to be a sum as the sequence goes off into infinity and beyond. By the way, email me if you have any questions as you work through any of these problems. Or, as always, just email me if you have any questions in general. So, alright, here we go. Find the first 5 terms of the sequence, defined recursively by 1, 1, a sub 1 being 1, a sub 2 being 1, and then a sub n being defined as 2 times a sub n minus 1 plus a sub n minus 2. So, like, hypothetically, say we have the first 2 terms, so I need to find the third term. So this says find a sub 2 minus, or 3 minus 1, which is 2, plus a sub 3 minus 2, which is 1. So we're going to do 2 times the sum of the 2 previous terms. 1 plus 1, and that's going to be 4. So a sub 3 is going to be 4. Let's find a sub 4, which is going to be 2 times a sub 3 plus a sub 2, so it's going to be a sub 4 equals 2 times a sub 3, which was 4, plus a sub 2, which was 1. And then 5 times 2 would be 10, so a sub 4 is 10. And let's find the fifth one. A sub 5 equals a sub 4 plus a sub 3. A sub 5 equals 2 times a sub 4, which is 10 plus 4. So 14 times 2 is 28. A sub 5 is then going to be 28. Okay, now writing a recursive rule. Now guys, I actually changed this one on your on the sheet that you have. I just didn't change it on a previous file. Anyways, so to get from 3 to 1, you can either subtract 2 or multiply by 1/3. To get from 1 to 1/3, you multiply by 1/3. To get from 1/3 to 1/9, you multiply by 1/3. To get 1/9 to 1/27, you multiply by 1/3. So this is going to be a geometric sequence with a rate of 1/3. And to get from one term, if we want to find a term value, we take the previous term of that sequence, and we said we're multiplying it by 1/3. So that's going to be the recursive rule, the recursive definition, but we need to specify the starting value of the sequence. Because if we don't specify that the starting value is 3, what happens if the starting value was 2? Then we would get 2, 2/3, 2/9, 2/27. You see the pattern. It depends on the start value here. All right, expand using Pascal's triangle. Pascal's triangle, guys, is just a fancy sequence. And we walked through the generation of it, where you add those two numbers. 1 plus 3 is 4, 3 plus 3 is 6, 1 plus 3 is 4. We've got ones down the diagonals, and then in the middle we take we add up the two terms right above it, and that generates the next list on the triangle. And we talked about how it was pretty neat that through Pascal's triangle we can get we can generate binomial expansion through it, which I think is really kind of an awesome application, where we start by looking at the expansion of the second term. So this would be like the 0 power, it's 1, the first power of a binomial, and these represent the coefficients of those powers: third power, fourth power, fifth power, sixth power, and so on and so forth, and it keeps going on to infinity. Right now we're looking at the third power, and we're going to try to expand that using the third power. So this winds up being the coefficients, or the multiplier of the terms. So we do plus 3 plus 3 plus 1, and we're going to start with the r, and then we're going to start to r to the third power, then we're going to do r squared, then we're going to do r to the first, and this becomes r to the 0. That's kind of redundant to write, kind of silly, but then we reverse the pattern with the 4s. It becomes 4 to the first, or 4 to the third, 4 to the second, 4 to the first, and then 4 to the 0 power. So when we're expanding it, we just simplify all this stuff out. It's r to the third, 4 times 3 is 12, r squared, 16 times 3 is 48, 48r plus 4 to the third, 64. And that is the binomial expansion, a very quick way to expand something to some higher power. So right now we're going to look at to the fourth power. So we're going to use this row of Pascal's triangle. It's going to be 1, 4, 6, 4, 1. And we're going to start with the a. So this is a to the fourth, a to the third, a to the second, a to the first, a to the 0. We don't have to write that. Then we're going to start down here with the second term. So this is going to be negative 3b to the fourth, negative 3b to the third, I'm going to add there, negative 3b to the second, negative 3b to the first, and then negative 3b to the 0 power, but we officially don't have to write that as well. So in the first term, we're going to get a to the fourth. We're going to simplify the second term. That's going to be negative 12. So we're going to have minus negative 12, a to the third b, and then it's going to be plus. It's going to be plus because it's a squared, and that's going to be positive. So then we're going to get 9 times 6, which is going to be 54, a squared, b squared. And then we're going to get negative 27 times 4. Right there, negative 27 times 4 is negative 108, so it's going to be minus ab to the third plus 3 to the fourth times 1, and it's going to be a positive 81, and then a to the 0 is just 1. So that's what we get when we expand it using Pascal's triangle. All right, guys, please email me if you have questions. Go back to the review guide that you did for the quiz. Go back to the questions on your quiz. We spent a lot of time going over those and articulating how to do those problems for you. But that's kind of where you need to be as far as studying. Good luck on the test on Friday, and I hope you all do well. Have a good day.